All right. Hope everybody's having a good day. Before we go ahead and get started, we have three proofs to finish up our current lesson on the double angle identities, and we'll hopefully get some volunteers up here in just a moment. I've actually seen some really interesting ways how to prove some of these, other than what I did. That's really what I'd like to see. But the big item tomorrow is your what? That's your exam. Now remember, it's going to cover basically two topics. You're going to have all the identities that we've been studying since before Christmas, but also the sum and angle identities. We want to make sure we're very familiar with those. Thank you, sir. Okay. She is not here today. Okay. And what about double angle identities? Will those be on the exam? No, they are not on the exam, but I do have a quiz next week that I'm going to go ahead and give you over double angle identities because I wasn't able to fit it in on this exam. Okay. As far as the exam goes, when we finish up the notes today, I went ahead, put together a couple of documents to help you out. If you go to the Google Classroom, okay. Okay, and you want to look at the current week. I've already got the next week set up, but if you look right here, I uploaded a couple of documents if you're looking for some extra problems just to practice prior to the exam. This one here, trig identity secret message. It's got 26 problems where you're just simplifying, but it's also a little fun because you could use the answers, match up, decode a message. And I really like this one because it's a pun. Okay, you guys know I'm big on puns. So that is available if you are interested. And also right below it, sum and difference extra examples. So I've given you some extra examples of the sum and difference identities, and this one has the key attached to it. All right, so after we finish up today, whatever time we have left after those three problems, I'm just going to go ahead and turn you guys loose. I'm going to pass back some papers. If you have questions on any of those as you look through them, okay, feel free to go ahead and ask me. But the only other thing I want to go ahead and ask, when we turn in assignments, we know that if we get them turned in the same day, they're not what? They're not late. Okay, the only thing I'm going to ask you from now on, if I'm in the middle of class, please don't interrupt the class. Bring it during a passing period, bring it at the end of school, whatever you need to. But please, if I have a class, I won't be accepting those. Okay, so just kind of a FYI there. All right, so here is the first one we have today. Cotangent theta minus tangent theta equals 2 cotangent of 2 theta. I've actually seen this done both ways today. First period started with the right side. Second period started with the left side. Both did a great job. But out of all today, I've only had to use the random number generator once. So let's see if we can keep that number as low as possible. Who volunteers to do this one? So many hands. Who? Okay, so I'm not seeing any hands. I got to go to the random number generator. Okay, are we ready? This one? Oh, the one right under it? Yeah, that's actually truly random. Okay. All right, well, let's see. 30. Actually, I believe that is Miriam. Yes. Okay, so Miriam says, I will volunteer. Like it when people volunteer. All right, so Miriam, will you start on the left or the right?
The left.
The left? Okay. Thank you, sir. Thank you, sir. Yes, sir. And nobody else needed the key from yesterday. Okay. All right. Oh, and I forgot to ask, would you like the headset?
No, I'm good.
You sure? Okay.
Yeah.
All right, so I'll just commentate. Okay, so she's converting cotangent and tangent to sine and cosine and getting a what? Common denominator, okay, which would be a product sine and cosine. Okay, over cosine sine. Okay, now remember our goal is to get to 2 cotangent of 2 theta. Okay, so where can we go from here?
Can I move it down?
Sure. Okay, she used an identity because remember, cotangent of 2 theta, how many identities or versions does it have? Actually, it has 3. And cosine squared minus sine squared is one of the 3, so that is cosine of 2 theta. So now we have cosine times sine. Okay. Now, is this okay what she's doing? She's multiplying by a version of 1. So long as she doesn't change the value, yeah, this is perfectly fine. Good. So this is going to give her 2 cosine of 2 theta. See, now multiplying by 2 cosine theta, sine theta, that is sine of 2 theta by our double angle identity. Cosine of 2 theta over sine of 2 theta would be cotangent of...
Would it just be 2 cotangent theta?
It would be 2 cotangent of what?
Of 2
2
theta?
theta.
For that.
Well, you have theta plus 2 theta.
Oh. So 2 theta.
Yes. So remember, whatever's happening to, say, the trig function, if it's squared or whatever the input is going to carry through the identity that we use. You're right. Yeah. Now, cosine of theta over sine of theta is just cotangent. Cosine of 2 theta over sine of 2 theta is cotangent of 2 theta. See, that 2 theta carries through. Perfect. That's it. QED. Good job. All right. So that is 1 down. Any questions on what she did? Okay. Next up. Sine of 2x over 1 minus cosine 2x equals cotangent of x. Volunteer. Connor, you want to do it? Does everybody agree? I'd be okay with that. Now, the person who's chosen may not be okay with that, but that's okay. All right, so Connor's going to help me out with this one. Okay, so he gets right to it. The numerator sine of 2x is 2 sine x cosine x by our double angle identity. And then 1 minus 1 plus 2 sine x. Okay, we're missing something.
Because since cosine 2 of x wants to negative distribute.
No, you're right about that.
Okay.
You're missing something in your identity, though. Does anybody see it? There we go, squared. Now, is everybody okay with how he went from the first denominator to this one? Does anybody need us to elaborate? Okay. All right, keep going.
Okay.
So 2 sine x cosine x.
And then the ones cancel.
Ones cancel. Okay. 2's cancel. You got a pair of sines that cancel. And cosine of x divided by sine of x will give you cotangent of x. There you go. QED. Perfect. Right to it. Good job.
Okay.
So, Connor, who are you wanting to show me the third one?
Savion.
Savion. Okay. Now, before you go ahead and come on up, there is something I want to show you about this, okay, to kind of help you out, because I'm encouraging people to go from, the right side, but is there anybody who worked from the left side? Okay, good. So you might have used this idea. If you're looking at sine of 2 theta, okay, this is going to end up being 2 sine of theta cosine of theta, right? Okay. Well, you may or may not have mentioned certain patterns or noticed them. I haven't brought them up yet. I'm definitely going to bring them up next week when I show you the power reducing identities, because they're very useful to you. But let's say we had sine of 4x. And I wanted to go ahead and apply the same identity. This is what I'm going to get. Okay, 2 sine of 2x cosine of 2x. Do you notice what happened? What's the pattern that remained consistent when I use the identity? There you go. The coefficient of theta is half what you originally started with. So here you had sine of 4x, so we had 2x. Okay. So if I had something like sine of 6x, what would it become? 3x. Okay. So that could potentially help people out for this one. And at the end, depending on what Savion, because I know who's coming up now, what he does or does not do, there is another identity I'm going to go ahead and show you that kind of helps with that. I'm going to kind of prove it. Okay. All right. So Savion, I will turn it over to you. Okay. Now, Savion, were you here yesterday?
Yeah.
Okay. Do you remember my hint?
No.
Okay. What was the hint I gave yesterday? Okay, on the right side, in that parentheses, we take out a GCF. So sine, cosine cubed, cosine. Okay, that was my hint if you didn't know where to start. So I'm going to pass back these papers while he does that. Oh, and I didn't ask you, do you want the headset?
Take your chair, Say yes.
Okay, then we're going to help you out. There you go. There you go. Do you want the headphones? Okay. All right. Turn it over.
Alright, so where do I start, guys? What should I do first? What's the greatest? Alright, Satish.
Take out cosines.
Did anybody else do anything different?
Yeah, you're happy with that. You pull out cosine sine.
Sine and what?
So you'll pull out a product.
Alright, so well, I guess I don't really need the equals. Alright, so first, you take out sine and cosine because they're the greatest common factor. So then you'll be left with Alright, what's the next thing, guys?
Okay, now that's what's going to be left.
Yeah.
What would you pull out
Oh.
to have that remain?
What do you mean, no? I thought I had to pull out sine and cosine.
Okay. So, yeah,
So,
it's
yeah,
gonna be
that's-
one big product.
Oh, so I still have to put equals? What? Yeah.
There you go.
Okay. So what's the next thing?
Then, so, like, starting with this, it's like cosine squared minus sine squared.
Yes. Well, I need my paper.
That's
No, wait.
no, the
Cosine
videos
squared
I've posted
minus
so
sine
far
squared
haven't got a lot
equals.
of hits.
What do they call it?
They're old. I did. Does anybody remember the old 80s? You may, because people kind of make fun of them in retro sense. The old 80s drug commercials about, just say no. Well, you know the real famous one where the parent is over the son. He's like, "Look what I found in your closet. Who taught you how to do this?" He's like, "You, all right? I learned it by watching you." Well, I did a parody of that with my son. Not on drugs, but on twerking.
Oh,
Because that was a big thing at the time. I'll show it to you.
Okay. Dude, I'm trying. You guys gotta help me. I didn't do the third one. Okay, so.
Okay, now.
Alright, yeah.
You're right there. What
Yes.
is cosine squared minus sine squared?
Cosine 2 times theta.
Okay, so cosine 2x. Okay. So we're going to substitute. So you've still got the 4 sine cosine times cosine of 2x. Okay. Now we're going to get a little creative here. Okay. Remember I showed you that sine of 4x would actually equal 2
Yeah,
sine 2x cosine 2x?
yes.
Well, you've already got the cosine 2x.
Oh,
Is there any way I can get sine of 2x?
sine of 2x.
Is there anything
Wouldn't
I
you
could possibly do with that 4?
just half it, right? You'd half it,
Okay.
divided
So
by 2.
I could break it up.
Yeah.
2 times 2. Okay.
Wait, 2 sine of x means
Well,
sine.
go ahead and put the 2 times 2.
Yeah.
And then write out the rest of the expression. Okay. And then you've got the cosine 2.
I'm sorry.
Okay.
My arm's getting
Now,
tired.
because of the way you rewrote the 4, 2 sine x cosine x, what is that? So just this portion right
It's 2 sine x cosine x. That's sine times 2 of theta.
Okay. So in this case, it would just be sine of
Yeah.
2x, right? So 2 sine of 2x times the cosine of 2x that we have. And remember, what did I show you that equal? 2 sine of 2x cosine 2x.
I don't remember. Oh, sine of
It
4x.
does equal sine of 4x. That's it. There you go. QED. Good job. Thank you. Now, let me go ahead and show you one more thing. In case you weren't convinced on the pattern that sine of 4x was actually going to give you this expression right here, let's go ahead and look at it similar to what we did when we were deriving these identities. If I have sine of 4x, is that equivalent to sine of 2x plus 2x? Because that's 4x, right? Okay, so it's another problem where alpha and beta are the same. So I'm going to apply the sum identity for sine. So I'm going to say sine of 2x times the cosine of 2x plus, because remember we keep the symbol, cosine of 2x sine of 2x. Sine alpha, cosine beta, plus cosine alpha, sine beta. But do you notice anything about those products? What are they? Are they the same or different? They're the same, right? Now, does it matter that cosine and sine are reversed here? Nope. So sine 2x, cosine 2x, plus cosine 2x, sine 2x would be 2 sine 2x, cosine 2x. See, they're like terms. So see, I was able to show again that that does equal sine of 4x. Just in case anybody was still having a little bit of a problem with that. Okay. Questions? Okay. Well, that is all I have. You've still got a good 23, 24 minutes. I would encourage you to go ahead and look at some of those documents that I posted. I can open the Chrome card if you want, or you can use your phone or your own Chromebook, laptop, whatever you have. Look at some of those expressions, practice them. If you have questions, let me know. Otherwise, I'm going to go ahead